Hello everyone and welcome of all you. Today in this class I am going to start a new chapter, continuity and differentiability. First I will discuss about continuity. So let's start our class. Continuity. Remember, continuity, if a graph does not break, then the function is called continuous function, otherwise it is discontinuous function. For example, take a function y is equal to sin x, y equal to sin x. The graph of this function is this is x-axis and this is y-axis, this origin. The graph of the function f of x. The graph of the function f of x is this point is 1 and these points minus 1 and is pi by 2 pi 2 pi minus pi by 2 minus pi minus 2 pi. Here the graph does not break at any points. Here the sine function, the graph of the sine function does not break at any points, therefore this function is called continuous function. We take another example. Y equal to f of x be any function and assumed the function, the graph of this function is the graph of this, assume that the graph of this function is this. The graph is not the graph is break this point. The graph is break this point, therefore the function is called discontinuous function, and this point is called point of discontinuity. This point is called point of discontinuity. The graph is break this point, therefore the function is called discontinuous function, and this point is called point of discontinuity. So a graph does not break, therefore the function is called continuous function, and otherwise it is called discontinuous function. Next, continuity at a point. Continuity at a point. Continuity at a point. Remember, a function f of x is said to be continuous. A function f of x is said to be continuous at point A if a function f of x is said to be continuous at point A if number 1, if limit x tends to a minus f of x is equal to limit x tends to a plus f of x is equal to f of a. Remember, a function f of x is said to be continuous at a point a if limit extends to a minus f of x is equal to limit extends to a plus f of x equal to f of a. That is this is called left hand limit. Left hand limit equal to right hand limit. Limit extends to a plus f of a is called right hand limit is equal to f of a. That is left hand limit equal to right hand limit equal to f of a. If left hand limit equal to right hand limit equal to f of a, then the function f of a is called continuous function. That is limit extends to a f of x equal to f of a. A function is continuous at point a if limit extends to a f of x equal to f of a. That is left hand limit equal to right hand limit equal to f of a. That is left hand limit is equal to limit extends to a minus f of x equal to limit extends to a plus f of x is equal to f of a. Next, we will discuss reasons of discontinuity. Reasons of discontinuity. Reasons of discontinuities. Number one, limit extends to a f of x does not exist. Number two, limit extends to a f of x does not exist. That is left hand limit not equal to right hand limit at x equal to a. Number two, f of x is not defined at x equal to a. That is left hand limit is equal to right hand limit at x equal to a, but f of a is not defined. Next, number three, limit extends to a f of x not equal to f of a. Limit extends to a f of x not equal to f of a. That is left hand limit equal to right hand limit at x equal to a, f of a is also defined but these are not equal. A function is said to be discontinuous if limit extends to a f of x does not exist. Limit extends to a f of x does not exist. That means left hand limit not equal to right hand limit at x equal to a. If left hand limit not equal to right hand limit, then the function is discontinuous at x equal to a. Second point, if f of x is not defined at x equal to a, that is left hand limit equal to right hand limit at x equal to a, but f of a is not defined, then the function is discontinuous at x equal to a. Number point 3, limit extends to f of x is not equal to f of a. That means that is left hand limit equal to right hand limit at x equal to a, f of a is also defined, but these are not equal. Then the function is called discontinuous function. continuity in an open interval. Continuity in an open interval. Continuity in an open interval. A function f of x is said to be continuous. Is said to be continuous in an open interval. In an open interval AB if it is continuous at each and every point of a comma b open interval AB. A function f of x continuous in an open interval a comma b if it is continuous at each and every point of open interval AB. The function is continuous each and every point AB. The function is continuous each and every point on the open interval AB. Then the function is continuous on the open interval AB. The function is continuous each and every point on the open interval a comma b. Then the function is continuous in the open interval a comma b. Next, continuity is in a closed interval. Next, continuity in a closed interval. Continuity in a closed interval. A function f of x is said to be continuous in closed interval a comma b if a function f of x is said to be continuous in closed interval a comma b if number 1 it is continuous in open interval a comma b. It is continuous. First condition, it is continuous in open interval a comma b. Number 2, limit x tends to a plus f of x equal to f of a. Number 3, limit x tends to b minus f of x equal to f of b. A function f of x is continuous in closed interval a comma b if the function is continuous in open interval a comma b, and also the limit x tends to a plus f of x equal to f of a. That means right hand limit is equal to value of the function at x equal to a. Number 3, point 3, limit x tends to b minus f of x equal to f of b. That means the left hand limit of this function is equal to the value of the function at x equal to b. Then the function is continuous in the closed interval a comma b. Next, algebra of continuous functions. Algebra of continuous functions. Algebra of continuous function. If f of x and g of x are any two continuous function, if f of x and g of x are any two continuous function, then f of x plus g of x, then f of x plus minus g of x and f of x into g of x are also continuous function. Remember, if f of x and g of x are any two continuous function, then the sum of this function is also continuous and the difference of this function is continuous and the product of this function is also continuous functions. That is, f of x plus g of x is continuous and f of x minus g of x is continuous and f of x into g of x is also continuous if f of x and g of x are two continuous functions. Number 2, c into f of x is continuous function. Number 2, c into f of x is continuous function where c is a constant. If we multiply a constant term by a continuous function, then the resulting value is also the continuous function. That is, c into f of x is a continuous function where c is a constant. Number 3, f of x divided by g of x is a continuous function all those points provided g of x not equal to 0. If f of x and g of x are two continuous functions, then f of x divided by g of x is also a continuous function all those points where g of x is not equal to 0. Next, most important points, remember, polynomial functions number 1, polynomial functions are continuous everywhere. Number 2, sin x, the sine function and cos function and sin x comma cos x and modulus x are also continuous everywhere. Number 3, tan x is continuous everywhere except odd multiple of pi by 2, except odd multiple of pi by 2. Next, number 4, log x is continuous in open interval 0, infinity. Remember these points. Polynomial functions are continuous everywhere. Sin x, cos x and modulus x are also continuous. Tan x is continuous except odd multiple of pi by 2. Next, log x is continuous in open interval 0 to infinity. Now, we will discuss some numerical problem related to continuity. So let's start. Exercise 5.1. Question number 1. Exercise chapter 5, exercise 5.1, question number 1. Prove that the function f of x is equal to 5x minus 3 is continuous at x equal to 0, comma, at x equal to minus 3 and at x equal to 5. Question number 1. Prove that f of x is equal to 5x minus 3 is continuous at x equal to 0, at x equal to minus 3 and x equal to 5. Solutions. We know that a function is continuous. Already we have learned a function f of x is continuous if and only if limit x tends to a, f of x equal to f of a. Then the function is continuous at x equal to a. If limit x tends to a, f of x is equal to f of a, then the function f of x is continuous at x equal to a. Here f of x is equal to 5x minus 3 at x equal to 0. Limit x tends to 0, f of x is equal to limit x tends to 0, f of x is equal to 5x minus 3. Therefore, 5 into 0 minus 3 is equal to minus 3. The limit x tends to 0, f of x is equal to minus 3. And f of 0 is equal to 5 into 0 minus 3 is equal to minus 3. Here limit x tends to 0, f of x is equal to f of 0. Therefore, this function f of x is continuous at x equal to 0. Therefore, since limit x tends to 0, f of x is equal to f of 3. F of 0. Here limit x tends to 0, f of x is equal to minus 3 and also f of 0 is equal to minus 3. Therefore, this and this are equal. Therefore, the function f of x is continuous at x equal to 0. The function is continuous at x equal to 0. Next, at x equal to minus 3. Next, at x equal to minus 3. Therefore, limit x tends to minus 3 x tends to minus 3, f of x is equal to limit x tends to minus 3, f of x is equal to 5x minus 3. This is equal to 5 into minus 3 equal to minus 15 minus 3. This is equal to minus 18. Next, f of minus 3 equal to 5x minus 3, 5 into minus 3. This is equal to minus 15 minus 3 is equal to minus 18. Here, limit x tends to minus 3 is equal to f of minus 3 is equal to minus 18. Therefore, this function is continuous at x equal to minus 3. Since limit x tends to minus 3, f of x is equal to f of minus 3. Therefore, f of x is continuous at x equal to minus 3. Next, at x equal to 5, therefore limit x tends to 5, f of x is equal to limit x tends to 5, f of x is equal to 5x minus 3. This is equal to 5 minus 5 minus 3. This is equal to 5 into 5, 25 minus 3, 22. Next, f of 5 f of 5 equal to 5 into 5 minus 3. This equal to 22. Here limit x tends to f of x tends to 5, f of x equal to f of 5 is equal to 22. Therefore, this function is continuous at x equal to 5. Next, we will discuss another question, question number 3. Question number 3. Examine the following functions for continuity. 3a. F of x is equal to x minus 5. Examine the function is continuity. Here f of x is x minus 5. Already we know that polynomial function is continuous everywhere. Already we have learned polynomial function is continuous everywhere. This function is x minus 5 is a polynomial function. X minus 5 is a polynomial function. Therefore, this function is continuous at all points of x. We know that polynomial function is continuous everywhere since x minus 5 is a polynomial function. Therefore, f of x is continuous at all points of x. Next, number 2. 3b. F of x minus 5 comma x not equal to 5. This is question function and the numerator and denominator are all polynomial functions, and also x not equal to 5. Therefore, this function is continuous provided x is not equal to 5. The function is continuous at all points of x provided x not equal to 5. Next, number C. F of x is equal to x square minus 25 divided by x plus 5. X is not equal to minus 5. X is not equal to minus 5. Here, x square minus 25, this is equal to x plus 5 into x minus 5. X plus 5. X plus 5 cancel. This is equal to x minus 5. Here, the x minus 5 is a polynomial function, therefore, f of x is also a continuous function, all points of x. Next, question number 4. Question number 4. Prove that the function f of x is equal to x to the power n is continuous at x equal to n, where n is a positive integer. F of x is equal to x to the power n is continuous. Prove that the function is continuous at x equal to n. Prove that the function f of x is x to the power n is continuous at x equal to n. We know that a function f of x is continuous if limit x tends to a function f of x is continuous at x equal to a if limit x tends to a, f of x is equal to f of a. Already we have learned a function f of x is continuous at x equal to a if limit x tends to a, f of x is equal to f of a. Therefore, at x equal to n, limit x tends to a, f of x is equal to limit x tends to a x to the power n. This is equal to n to the power n. Next, f of n is equal to n to the power n. Here, limit x tends to f of x is equal to f of n is equal to n to the power n. Therefore, this function is continuous at x equal to n. Since limit x tends to a, f of x is equal to f of n. F of n. Therefore, f of x is continuous at x equal to n. Thank you.